All right, let's say that I have this series right over here. And a series is just a sequence of numbers that's basically just added together. Now, I can represent the series using something known as sigma notation. So, this right over here is an example. Now, what does this all mean? So, when you have n is equal to 1, n is just some sort of variable, okay? So, we start at n is equal to 1. So, you can think about this 1 as our starting point, and then n is equal to 5 is our ending point. And this right over here, you can think about this as basically, it's sort of like a function, okay? So this 8n minus 4 is sort of like a function. Now what you're going to do is imagine if you plug in 1 in for n. So imagine if you place in 1 in for n. You're going to get 8 times 1 minus 4, which is just equal to 4. All right. Now imagine if you plug in 2 in for n. So imagine if you plug in the number 2 in for n. You're going to get 8 times 2. So 8 times 2, which is 16. And 16 minus 4 is equal to 12. So you're going to have 8 times 2 minus 4, which is equal to 16, minus 4, which is equal to 12. Now imagine if you plug in 3 in for n. So 8 times 3 minus 4 is equal to 20. Right? 8 times 3 minus 4 is equal to 20. You plug in 4 in for n. So you're going to have 8 times 4 minus 4, which is just equal to 28. And finally, you're going to plug in 5 in for n. So 8 times 5 minus 4 is equal to 36. All right, so basically what we're doing is we're starting at n is equal to 1, so we plug in n is equal to 1 for this, and we do it all the way for basically all the integers that are in between 1 and 5, right? We're doing it for all the integers that are in between 1 and 5, and then we're, stopping at 5. And what we're doing is we're taking all of these numbers, and we are adding them together, okay? So yeah, that's basically what we're doing, right? 4, 12, right? You see 20 here, you see 28 here, you see 36 here, right? We're taking all of these numbers and basically we're, plugging from 1 to 5 into this formula and we're adding all of these numbers together. So one way you can do this is you can say, okay, imagine if this is the first term, imagine if this is the second term, and imagine if this is the third term, okay? So what we're basically doing is we're taking the sum from the first term to the third term, right? Up to the third term. And we're doing this for a function 5n, right? Because when you plug in n is equal to 1 here, you're just going to get 5, right? Which is the first term. When you plug in n is equal to 2 into this, right? Because remember, when you're doing summation, you're doing the sum from n is equal to 1 and for all the integers that are in between 1 and 3. So what's an integer that's in between 1 and 3? Well, that's going to be 2, right? So you're also going to, so basically you're going to do 5 times 1, and then you're going to do 5 times 2, and this is going to be plus 5 times 3, and then we stop. All right, so we're basically doing, we're plugging in n is equal to 1, n is equal to 2, n is equal to 3 into this function. We stop at n is equal to 3 because that's basically my upper bound. And yeah, that's basically what this series is right here. Another way you can think about this, so this is like another way you can think about this, but basically imagine if this first term is your 0th term. Imagine if this term right over here is your first term, and imagine if this one right over here is your second term. Okay, now what you can do now is you can say, okay, this is the sum from n is equal to 0 up to the second term, right? And once again, because we're doing multiples of 5, we have to have this 5n at the front. But now the problem with this is that when we plug in n is equal to 0 here, we get 0 times 5, which is just 0. But you notice how the 0th term is 5, right? So what we have to do is we have to add 5 to the end of this summation notation. Because now notice how when you plug in n is equal to 0 into this function right over here, you get 5 times 0 plus 5, which is 5. And 5 represents our 0th term, right? So kind of an easy way to check that you have the correct answer is you could just list out the first couple of terms, right? If you plug in n is equal to 1 here, you get 5 times 1 plus 5, which is just 10. Plug in n is equal to 2 in for here, you get 5 times 2 plus 5, which is 15. So yeah, everything matches up. And in fact, you can do summation notation. What I notice immediately is that if I want to get to the next terms, I have to add 7. So for my summation notation, what I can do is, okay, I can say I'm starting from, let's say, the first term, so n is equal to 1, and then notice how I'm ending at the 4th term. So my ending is 4. Now, because I'm doing multiples of 7, right? Notice how these are multiples of 7. What I do is I could just put a 7 in here, right? Because as n increases, we're going up by multiples of 7. And this is actually the answer, right? Notice how when you plug in n is equal to 1, you get 7 times 1, which is just 7. If we plug in n is equal to 2, you get 7 times 2, which is 14, which matches this term, right? And you're adding all of these terms together up to the 4th term. Another way you can do this, imagine if the first term, instead of the first term, imagine if this term right over here is the 0th term. And instead of this 28 as the 4th term, imagine if this is the 3rd term, right? So you're going to have 0, 1, 2, 3, right? So this is going to be the 3rd term. So we're starting from n is equal to 0 to 3. And once again, we're going to have this 7n. As our bounds change, right? Notice how our bounds change, but we still keep the 7n because we're still going by multiples of 7, right? But notice how if I plug in 0 into n, I get 7 times 0, which is equal to 0. But my first term isn't 0, right? So what we have to do is we have to add 7 at the end of this. Because now notice how if I plug in 0 in for n, I get 0 plus 7, which is 7. And that matches up here. And I'm still maintaining my multiples of 7, right? I'm still increasing by 7 each time as n increases. So summation notation. So how can I do this? Well, okay. So let's just see what the pattern is. So notice how as I go to each term, right? Actually, just these two. Notice how as I go from one term to the next term, I'm adding 4 each time. This ... represents that basically we're going plus 4, plus 4, plus 4, and we're going all the way up to 151. So we can say that this series right over here starts from, let's say, the first term, and hold up, what the hell? Because look, for the previous problems right over here that I've done, right, notice how for my examples, I only have 3 numbers for my examples, right, or 4 numbers for my examples. So I know that, for this series right over here, right, I'm going from the 0th kind of term, which is this right over here, and I'm going up to the 2nd term, which is the last term, right? So I'm going from my first term to my last term of whatever, this series is. But for my example right over here, I know my first term is 7. I know my first term is 7. But what term is this, right? What term is this? Well, recall that you have kind of a formula for this. First term is, right? So I know what my first term is. I know what my common difference is. The common difference is basically the number that you add each time to get from one term to the next. So the number I have to add each time to get from, let's say, 7 to 11 or 11 to 15 is just 4, right? So 4 is going to be our common difference. I know that. And I know that whatever a sub n is, well, that's going to be 151, right? So because I have these 3 variables that I know, I can just solve for n, and it'll be all good. So let me show you what I mean. So all I'm going to do is I'm going to say, okay, 151, which we know is a sub n, right? It's a sub some unknown term, right? This is an unknown term. So 151, we don't know what term it is, but we know that, it's 151. That's going to be equal to the first term plus n minus 1, right? We don't know what term it is, but we know that at this specific term, we're going to get 151, right? So n minus 1, and it's going to be times the common difference, which is 4. So now what we can do is we can subtract 7 from both sides. So 151 minus 7 is going to be 144 equals 4 times n minus 1. We're going to divide both sides by 4. So we're going to get 144 divided by 4, which is equal to 36 is equal to, these 4 cancels out. So we're going to get n minus 1. And we're going to get that n is equal to 37. And what this n equals 37 is basically saying that, well, this term right over here is the 37th term. 37th term. So now that we know that this 151 is our 37th term, we can put a 37 up here, right? Because now we know where we're ending, right? Now we know which term we're ending on. Now, we know that every time we're going from one term to the next, we're increasing by 4 units, right? So I'm just going to put a 4n to the front because this basically gives out multiples of 4, right? Kind of increasing. Now what I've done here is I just placed the 4n at the front because notice how as n goes from 1 to 2 to 3 to 4, notice how we're increasing by 4 each time. However, notice how if I plug in 1 into 4n, I get 4 times 1, which is just 4. So for this summation right over here, for this sigma notation, our first term is equal to 4. But notice how for this series right over here, our first term is equal to 7. So what I have to do is I just have to add a plus 3 at n. Because now if I plug in 1 in for n, I get 4 times 1 plus 3, which is just 7. And I'm increasing by 4 every time. All right, so whenever your common difference is some number, what you're going to have for like a series in sigma notation, you're going to have that common difference times n, right? Because you're increasing by this common difference every time you're moving up a term. So yeah. And this plus 3 at the end is just, so we can say that, okay, we're starting from n is equal to 1, so basically the first term, and where are we ending? Well, we don't know where we're ending. That's what we're trying to find out. And where we're ending is basically the last term, okay? So this is basically our ending point, right? This is basically our ending point. And we want to find out which term this is, right? Because this right over here represents the first term, right? So we want to find out what term is our last term, basically what term is our last term, so that, we know where we end, and we can put this ending bound on top. Now, once again, I'm just going to write out this formula. So basically, we can set up this equation. So we know a sub n, basically our ending point right over here, we know that's equal to 71, right? This is going to be equal to a sub 1, which represents the first term, plus n minus 1. N basically represents the specific term. So we don't know what term it is. So we're going to put in just the n minus 1 here. And this is going to be times d. And d is our common difference. So each time we're moving up this series, we're adding 2 each time. We're adding 2 each time. So our common difference is going to be 2. Okay, so we can set up this equation. Whenever you're doing these types of problems, the only thing that should be unknown is this n right over here. N basically represents the specific term it's on. So basically, right, for my first term, my n value is going to be equal to 1. Right, for my second term, this is my second term right over here, our n value is going to be equal to 2, right? But we don't know what n value, for 71 is, right? We don't know what specific term it is, right? We know this one's the second term, this one's the third term, but we don't know which term this one is, right? So we're solving for n in this case. So, we're just going to do the same steps we have done before. We are going to subtract 1. We're going to subtract 1 so that, we get 70 is equal to n minus 1 times 2. If you're just wondering why I didn't divide everything by 2 at the start, it's because notice how you have this 1 plus n minus 1 times 2. So in fact, you're actually going to get, if I divide everything by 2, I'm going to get 71 over 2 is equal to 1 divided by 2, which is just 1/2 plus, n minus 1. And I could do this step, but I don't like fractions, so let's just do it this way. So yeah, what I'm going to do is I'm just going to subtract 1 from both sides. So I guess 70 is going to be equal to n minus 1 times 2. I'm going to divide both sides by 2. So I get 35 is equal to n minus 1. And if I add 1 to both sides, I get 36 is equal to n. So I am on the 36th term. This right over here is the 36th term. All right, so now for my sigma notation, I can say that I'm starting from the first term and I'm ending at the 36th term. And notice how I'm going up 2 each time, so I'm just going to put a 2n at the front. Now, if I plug in 1 into 2n, I'm going to get 2 times 1, which is just 2. but my first term is 1, right? So how do I fix this? Well, I'll have to put a -1 at the beginning, right? Because now, notice how when I plug in 1 in for n, I get 2 times 1, which is just 2, and 2 minus 1 is 1, and, well, I'm all good. And because I have this 2n at the front, it basically means that I'm adding here. All right, and I'm trying to find out the sum. Let me just put a dot 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 here, actually. Okay, so let's say if I have this sequence right over here, and let's see if I want to find the sum of the first 8 terms of this sequence. So if I found if I found what the 8 terms were and I added them all up, what is their sum going to be equal to? First question you have to ask yourself is this an arithmetic? Is this an arithmetic sequence? I know I'm spelling that way wrong, but it's fine. So the first question you should be asking yourself is this an arithmetic sequence or is this a geometric sequence? Arithmetic basically just means that you're adding. So basically to get from one term to the next term, you're going to be adding by some amount. And geometric sequence is just, if you want to get from one term to the next term, you're going to be multiplying by some amount. So an example of an arithmetic sequence would just be 1 plus 2 plus 3 plus 4. An example of an arithmetic sequence would be 1, 2, 3, 4. Remember that this right over here is a sequence, right? So a sequence is basically just kind of a sequence of numbers, right? Sequences are different from series. Series are basically a sequence. So series basically represents a sequence of numbers, except you're adding each time, okay? So if I have, let's say, 1, 2, 3, 4, this would be an example of an arithmetic sequence because you're adding 1 each time to get to the next term, or you're adding by some amount. A geometric sequence would be 1, 2, 4, 8. You're multiplying by 2 each time to get to the next term. Now this right over here is actually a geometric sequence because notice how to get from one term to the next term, I'm multiplying by 1/4, okay? So this is going to be something known as the common ratio. It's the thing that you're multiplying each time to get to the next term. So, each time I'm multiplying by 1/4 to get to the next term. That's my common ratio. Your common ratio is always going to be multiplication. Some people might be saying, okay, to get from 36 to 9, I'm dividing by 4. Therefore, my 4 is going to be my common ratio. However, this isn't the case because your common ratio should be multiplying by some number. So in this case, I'm multiplying by 1/4. So 1/4 is my common ratio. You wouldn't say that your common ratio is 4, okay? It's always going to deal with multiplication. Now for a geometric sequence, this is going to be the formula. So in this case, let's just kind of plug in everything into my formula. So S sub n, basically the sum up to the 8th term, is going to be equal to the first term, which we know is 36, times 1 minus r to the n. So r basically represents the common ratio. And my common ratio in this case is 1/4. So it's going to be 1 minus 1/4 to the n power. So basically to the 8th power. Right? Because notice how this S sub n and this n right over here match up. Right? So if I'm trying to find the sum up to the 8th term, well, my n value is going to be 8. Okay? And it's going to be divided by 1 minus r, or just 1 minus 1/4. All you need to do is just get a calculator, and you can just do that. So it's going to be 1 minus this 4 times 36. All right, so it's going to be about 48. This is going to be about 48. Okay, and let's say if I have this sequence right over here. Find the sum of this sequence. Okay, so basically what we have right over here is something known as an arithmetic sequence because we're adding 5 each time. Let's say if I want to find the sum of everything in here, right? So once again, I have this dot dot dot, and this just basically means that I'm going 4, 9, 14, 19. I'm going all the way up in multiples of, adding 5 each time, and then going up to 64. So how can I find the sum of all of these terms? Well, notice how in my arithmetic sum formula, it's basically the sum for an arithmetic sequence, we need to find out what our first term is, and we need to find out what our last term is, right? So this last term right over here. and we have to find out what n is equal to. But now notice how for the arithmetic sum formula, you need to find out what the first term is, you need to find out what the basically a sub n is, so the last term, and we need to find out what n is equal to. So how can we do this? Well, if I just plug in everything I know into this formula, I'm going to get basically s sub n. That's going to be equal to my first term, I know is 4, plus my last term, right? So it's going to be the average between the first term and the last term. I know my first term is 4. I know my last term is 64, right? That's my last term. And because this is the average, I divide by 2, and it's going to be multiplied by n. N basically represents the amount of terms there are. So how can I find n? How can I find n? Well, the n value, so basically the value of n right over here, basically represents the n value for this term. Or arithmetic sequence, you're going to use this formula, right? And basically, what we're going to do is we're going to plug everything we know into here. We're going to solve for n, and once we have the n there, we're going to plug this n back into this n, right? The value into here, and we're going to get the sum. Okay? So here's how I'm going to do it. So I'm going to get 64. That's basically a sub n, right? That's a sub n. That's going to be equal to the first term, which is a sub 1, plus n minus 1 times d. D is our common difference, so that's going to be 5. Now we're going to get 60 is equal to n minus 1 times 5. If we divide both sides by 5, I get 12 is equal to n minus 1, and I get that n is equal to 13. And all this is saying is that this is the 13th term. This is our 13th term right over here. So that means my n value right over here is 13. And I'm trying to find the sum up to the 13th term, okay? So now I'm going to get the sum up to the 13th term is going to be whatever all of this evaluates out to. So this is going to be 68 divided by 2, and it's going to be multiplied by 13, which is 442. And that's going to be my answer. System of linear equations. So basically, what I have here is this right over here represents a parabola. In this case, because I have a negative in front, it's going to basically represent a negative parabola. Let's just say it looks something like this. Now this right over here, my second equation, represents a line. Okay? This right over here represents a line. And I'm basically trying to find the intersection points between this quadratic equation and this line. Now it could potentially have two solutions, but sometimes it might only have one solution, as you can see here, and sometimes it might even have no solution if the line is up here and the parabola is down there. So, there can be 3 scenarios. Now, what I'm going to do is, first I'm going to basically solve for y here. So I'm going to add y to both sides, so I get y plus 3 is equal to 2x, and I get that y is equal to 2x minus 3. Now I'm going to plug y in. Basically, I'm going to plug 2x minus 3 in for y, up for the quadratic equation. All right, so whenever I'm doing these types of problems, I like to use substitution, okay? So I'm going to get 2x minus 3 is going to be equal to negative 2x squared minus 10x minus 3. Now, what I'm going to do is I'm going to move everything to one side. So if I subtract 2x from both sides and I add 3 to both sides, so I subtract 2x from both sides and add 3 to both sides. So I get negative 2x squared minus 12x, right? Because negative 10x minus 2x is negative 12x. And this negative 3 and this positive 3 cancels out here. And this negative 3, this positive 3 cancels out here. So I just get negative 12x squared minus 12x is equal to 0. Okay? Now what I can do here is I can factor out a negative 2x. So if I factor out a negative 2x, I'm going to get x plus 6 on the inside. Okay? Yeah, I factor out a negative 2x from both terms, so yeah, I get this. Now, if I'm trying to solve this equation, either this part of my equation is equal to 0, or this x plus 6 is equal to 0. Now, either x is equal to 0, or x is equal to negative 6. Now remember that when you're solving a system of linear equations, so once again, if I have something like this, remember that the intersection points are coordinates. So they have a x and they have a y value. All right. So whenever you're trying to write out solutions for system linear equations, it should always be a coordinate. Okay. And in this case, right over here, I get the x coordinate for these values, and now all I have to do is find out the corresponding y values. So what I can do here is I'm going to use my easier equation. All right, so this is my basically the linear part of my equation. This is the quadratic basically equation, right? And what I'm going to do is I'm going to use the linear equation. I'm going to plug in x is equal to 0 here. So I get 2 times 0, which is 0, and I basically get that 3 is equal to negative y, or y is equal to 3. My bad, guys. I forgot to put this negative sign in the front. Y is equal to negative 3, right? Because we divide by negative 1 on both sides. And well, if I plug in x is equal to negative 6 into my linear equation, I'm going to get 2 times negative 6, which is negative 12 minus y equals 3. And solving for y, I get y is equal to negative 15. So when I plug in negative 6 in for x, I get negative 15 out for y. Those are going to be my two solutions. Now, I've actually graphed this on Desmos, and you can see how we have one intersection point, 0, negative 3, and the other intersection point is negative 6, negative 15, which is what I have here. Okay, given that they're in grade 9. Now, how can we solve this using basically tables? So this right over here is basically conditional probability, but you're using a table. All right. So this table right over here basically has 9th graders, they have 10th graders, and basically gives them, how many 9th graders like water as their, favorite drink, how many 10th graders likes water as their favorite drink. That's 20. So 15 plus 20 gives me 35 total students that like water. And then, there's 30 9th graders in total. There's 10th graders in total. 30 10th graders in total, okay? Now, what is the probability that a random selected student prefers juice given that they're in grade 9? Okay, so how can I solve this problem? Well, look, we're given that they are in grade 9, all right? So we're given that our student right over here is in 9th grade. And how many total students are in 9th grade? That's 30, right? We have 30 total students in 9th grade. And we're trying to find out the probability that a randomly selected student prefers juice. So this is basically asking us how many 9th graders prefer juice. And well, 10 9th graders prefer juice, right? We have juice right over here, and we have 9th graders right over here. So 10 9th graders prefer juice. So the probability that I get a random student from 9th grade that prefers juice is 1 over 3. I could just change it up like this. All right. What's the probability that a randomly selected student prefers soda given that they're in grade 10? Given right over here is basically telling us that we know 100% that our student is in 10th grade. And what is the chance that this 10th grader prefers soda? Well, 5 10th graders, we know that 5 10th graders right over here prefer soda, right? And how many 10th graders are there in total? 30. So 5 over 30 gives me the probability that a 10th grader, if we're given that, we have a 10th grader, which we have 30 of them, how many of them prefer soda, which is 5 in this case. All right. So, if you have, what's the probability that a randomly selected student is in 8th grade? Well, notice how for this table right over here, we have no 8th graders. So actually, if we're selecting a random person from whatever this school is from, it looks like this school only has 9th and 10th graders. So the probability of me picking a student that's in 8th grade from this school is going to be 0%. All right, so it's going to be impossible. Recall that, probability is from 0 to 100%. So 0% to 100%. Where 0 is impossible and 100 is 100%. It's guaranteed to happen. Okay. From kind of the examples I've shown before, I've kind of proved that the probability of A given B is equal to the probability of A and B divided by the probability of B. What does this all mean? So basically, right, the probability of A in this context represents what's the probability that a student prefers soda. And in this case, the probability of B in this case represents the probability of a student being in grade 10. So the probability of a student preferring soda given this straight line over here basically represents given. So the probability of a student preferring soda given that they are in 10th grade is going to be the probability that the student is in 10th grade and likes soda divided by the probability of the student even being 10th grade in the first place, right? And that's literally what we did with the table, right? We said, what's the probability that a student prefers soda given that they're in 10th grade, or given that they're in 10th grade? So, it's going to be the probability of a student being in 10th grade in the first place, and the probability of 10th grader liking soda, well, that's going to be 5, right? The probability of a student liking a soda and being in 10th grade, right? That's why when I draw these two kind of lines, there's this intersection point between the two kind of things, and that represents the probability of someone liking soda and being in 10th grade, right? It's where these two sets intersect. Okay, so that's kind of where we get the formula from. So this is kind of like a more concrete thing. Now, if I multiply both sides by the probability of B, so if I multiply both sides by the probability of B, notice how the probability of B's here cancel out. So I get another formula from this. I get that the probability of A and B is going to be equal to the probability of B times the probability of A given B. So notice how this formula is pretty powerful, because just from this formula that we kind of saw here, I kind of proved that the probability of A and B is equal to the probability of B times probability of A given B, just by simple multiplication. And I'll do more probability stuff for algebra 2. You got to know, for algebra 2, you got to know what an independent event is. Okay, and then I have like a little spinner in the middle. Like this. I can just spin this thing around and then see what color it lands on. Now, if I flip this coin, so if I flip this coin first and I get some result, let's say I get heads, does this affect the probability of me getting pink when I spin the wheel? So let me rephrase this. So if I flip my coin and let's say I get some result, does my result affect the probability of this other event? And if it doesn't, then it's something known as an independent event. Basically, these two events right over here, right, they don't affect each other. So if I flip this coin right over here, it's not going to affect the probability that I land on red for this spinner, right? These two things are completely separate from each other. However, an example of a dependent event would be, let's say if I have a bag of marbles, okay? So let's say this is my container. And let's say if I have a bag of marbles, right? Let's say if I have 4 red marbles, and let's say if I have 4 blue marbles. Now if I pick a blue marble out of this container and I left it aside, so let's say if I took this blue marble and I left it aside, right, then that's going to affect the probability of me getting a red marble the next turn. All right, what do I mean by that? So think about it, right? At first, the chances of me picking a red marble out of this container is going to be 1/2, right? Because there's 4 red marbles, there's 4 blue marbles. So the probability of me picking a red marble is going to be 1/2. Now, after I pick a blue marble, let's just say I pick a blue marble out of this container and I set it aside. Well, notice how the probability of me picking a red marble now is going to be 4/7, right? Because there's no more blue marble, so that means there's going to be 7 marbles in total, and there's still 4 red marbles. So when I pick this blue marble and I set it aside, leaving it out of the container, right, that affects the probability of me picking a red marble in the next turn. So if, doing one event has an effect on the probability of another event occurring, so if me picking a blue marble has an effect on the probability of me picking a red marble on the next turn, well, these are something called a dependent event. So in this case, what I can do is, okay, here's kind of the process. Let me group these two things into 2 sections. So for x to the 3rd power and x to the 2nd power, I can factor out an x to the 2nd power, right? And for this negative 4x and this negative 4, I can factor out a negative 4. Notice how these two things are the same. So I can combine these into one thing. I can combine the x plus 1s into one thing. And I can combine the x squared minus 4 into another part. Now x squared minus 4 is the difference of 2 squares. So it's going to be equal to x plus 2 times x minus 2. And don't forget the x plus 1. That's going to be our answer. That's going to be the fully factored form for this. And we also have rational equations. All right, so how can we solve this rational equation? Well, what I'm actually going to do is I'm going to give you a pretty big clue. I can rewrite my denominator as x times x plus 1. Okay, that's my clue to y'all. I can factor out this denominator. So how can I do this problem? Well, first of all, I have to know what my restrictions are. What can x be equal to? X cannot be equal to 0, and x cannot be equal to -1, right? Because plugging in x is equal to 0 makes my denominator equal to 0 here. Plugging in x is equal to -1 makes my denominator here and here, equal to 0. So, I can't do that. Now, what I want to do is I want to get a common denominator. So what I can do is I can multiply this part of my equation right over here on the top and the bottom by x. Because now notice how I have my common denominator, which is just x times x plus 1. So whenever you're doing equations where it's involving rational equations, basically, your denominator is basically, it's always kind of, your denominator is always going to kind of be, the factored thing. So whenever you're doing rational equations, if there's any chance that, you factor something and you get something similar to kind of another part of an equation, well, chances are it might be the greatest common fact. So if you're able to sort of factor out the denominator, it's going to give you pretty big clues on what might be the common denominator. In this case, my common denominator is x times x plus 1. So if I already have this x plus 1 part in this part of the equation, I just have to multiply the top and the bottom by x to get what I want. And for this 1 right over here, I can rewrite 1 as x times x plus 1 divided by x times x plus 1, right? I can rewrite 1 as this. So putting everything together, I can write it as this. So x times x plus 1 divided by x times x plus 1. And then this is going to be minus 1 over x times x plus 1. And this is going to be equal to, so this part of my equation, negative x times x is negative x squared. And this is going to be divided by x times x plus 1. Now, because we have a common denominator here, we can actually combine the fractions. Right? In case you don't get this step, imagine if you have 3/4 plus 1/4, you can combine this into 3 plus 1 over 4 because you have a common denominator, right? Or 4 over 4, which is equal to 1, right? So you can combine these two fractions if they have a common denominator. Same thing we have here. Now, if I distribute this, I'm going to get x squared plus x minus 1 equals negative x squared. And all of this is going to be divided by x plus 1. This is going to be x times x plus 1. Now, because our denominators are equal to each other, well, we can kind of set the numerators equal to each other. So we can set the numerators equal to each other, and we're going to get just this. If I add x squared to both sides, I just get 2x squared plus x minus 1 is equal to 0. And I'm pretty sure we can factor this by grouping. So if I multiply the first term and my last term, I'm going to get negative 2. Now, what two numbers multiply out to be negative 2 and add up to be 1? Because 1 is the coefficient of my x term. So what two numbers multiply out to be negative 2 and add up to be 1? Well, the correct combination is going to be positive 2 and negative 1. So I can actually rewrite x, this 1x right over here, as, so I'm going to have 2x squared plus 2x minus x minus 1 is equal to 0. And notice how I didn't change the value of this expression because, this equation, because 2x minus x is equal to 1x. Now I can factor this by grouping. For these two terms, I can factor out with 2x. So I get 2x times x plus 1. And in these two terms, I can factor out a negative 1. So this x plus 1. Notice how these two things are the same, so I can combine them into one term. I get x plus 1 is equal to 0. And then it's going to be, so we have 2x minus 1 times x plus 1 is equal to 0. And either x plus 1 is equal to 0 or 2x minus 1 is equal to 0. Now, the solutions that I get is either x is equal to -1 or x is equal to 1/2. Now, the thing is, remember in the beginning, I said how x cannot be equal to -1, which means that this isn't a solution. This is something known as an extraneous solution. So my final answer is x is equal to 1/2. That's going to be my answer. Now I can check my answer. Once again, if you're unsure about, this equation, you can always check the answer by graphing. So my first function is 1 over x, 1 minus 1 over x squared plus x, right? And then this is going to have to be equal to -x plus 1. Right? Yeah, these two things. Okay. Notice how they have an intersection point at 1/2, and then nowhere else. Nowhere else do they have intersection points. Now let's say if I have y is equal to 5 times the cube root of x plus 5. Let's say if I want to find the inverse function for this. So how do we do this? Remember, your first step should be switching the x and y's. And get x is equal to 5 times the cube root of y plus 5. Now let's just solve for y. So in this case, I'm going to subtract both sides by 5. I'm going to divide both sides by 5 so that these cancel out and I get x minus 5 divided by 5 is equal to the cubed root of y. Now what I can do is I can just cube both sides so that, this cancels out and I get that y is equal to x minus 5 over 5 to the third power. And this is also known as, our inverse. So this is what our inverse is equal to. All right, let's just do another quick one. So what you're going to do is, let's just say this is y, okay? So whenever you see f of x and you're dealing with like an inverse function problem, just replace it with a y. Now, if we're trying to solve for the inverse for this, what we can do is we can just swap the x and y values. Anyways, what we're going to do now is we're just going to cross multiply. So I'm going to get y minus 5. I'm going to get y minus 5 is going to be equal to 2yx plus x. Now what I'm going to do is I'm going to move all the y's to one side and all the non-y's to the other side. So what I can do now is I'm just going to add 5 to both sides. So I get y is equal to 2yx plus x plus 5. Now what I'm going to do is I'm just going to subtract 2yx from both sides. So I get y minus 2yx is equal to x plus 5. Notice how these two terms have a y, so I can factor this out. And it's going to be equal to x plus 5. So if I divide both sides by 1 minus 2x, I get x plus 5 divided by 1 minus 2x. And that's going to be our inverse function. That is going to be our inverse function.